Good morning, honorable government officials, distinguished guests, ladies and gentlemen, and those who are joining us online today. Welcome to the Hong Kong University of Science and Technology's Climate Adaptation and Resilience Conference, CARE2022. I'm Winnie, this morning's MC, and I'm also a proud alumni of HKUST. Welcome. On behalf of the Hong Kong University of Science and Technology, I would like to give you all a warm welcome to this lovely Saturday morning at the Shaw Auditorium Theatre. 4 years ago, HKUST presented CARE2018, focusing on climate adaptation, that HKUST had a significant scholarship to share. This year, we're thrilled to welcome you here today to our CARE2022 conference, with lots of updates on climate mitigation, adaptation, and resilience to share. We welcome you to take photos during the conference and share your thoughts on LinkedIn and Facebook using the hashtag CARE2022. And next, may we now invite Professor Yike, Provost of the Hong Kong University of Science and Technology, onto the stage for the welcome speech. Let's put our hands together for Professor Guo, please.
Secretary for Environment and Ecology, Mr. ZHAI CHENG, Under Secretary for Development, Ms. Debbie Lan, distinguished guest partners, ladies and gentlemen, good morning. Thank you all for coming to our university on Saturday in support of our flagship Climate Change Conference for 2022. I'm a provost only a week, so this is the first conference. Actually, I gave the welcome speech. I'm greatly honored. It's my great pleasure to welcome you all here for the first time since I becoming a provost in this university. In fact, this subject is very dear to me. I remember 15 years ago when my daughter tried to pick up an area for study. And I asked her, what area you want to study? She said, climate change. And I said, why? She said, it's my generation's duty to protect the earth. So I was very moved. Since then, she told me a lot about the climate change. So this subject is very dear to me. And I'm a data scientist and AI guy. So also I myself also studied this area and published a few papers. So I know, as with our world's many other pressing issues, and the tackle climate change will require the concerted efforts on the multiple fronts. In particular, government support is vital to meaningful progress. I'm delighted to see representatives of so many government bureaus and departments here today. Thanks also to participants from public bodies, professional organizations, business chambers, and corporates. Your presence shows how much importance you attach to climate change. The first CARE conference held in 2018 is fruitful discussions that leads to the report with public recommendations to our government. This year, we have timed CARE 2022 to take place soon after the COP27, so we can reflect on the discussions at the multilateral levels and bring it close to the home. 4 years since we launched the first conferences, and we have not forgotten about the dangers posed by extreme weather and the urgency of emergency preparedness. Compared to many parts of the world, Hong Kong's robust infrastructure provides excellent protections against typhoon, landslide, and flooding. But such safeguards don't mean we are immune to the risks. There are new threats we must face, such as extreme heat, sea level rise. By having you here at this 3 days conference, we hope to pull together a broad range of expertise to chart the way forward for our city and our region neighborhoods. At HKUST, we are committed to developing sustainable solutions for society. Research on severe weather is a major part of our work in this area. Our scholars, with a wide spectrum of expertise, have been put efforts in many areas. Among them is a team working to improve the prediction of extreme air pollution episodes. Others are studying the intense rainfall patterns around the world, the El Nino effect, and the rising sea levels. You will hear more about their research at the workshops this afternoon and tomorrow. The third day of this conference is dedicated to green finance, an emerging field prompting capital flows towards low-carbon, sustainable, and climate-resilient projects and products. Well, we strive to untangle the many scientific myths behind the climate change. It is also indispensable to mobilize the right finance tool so that we can achieve sustainable environmental outcomes. We are currently coordinating the Green Finance Research Project funded by RGC, in which scholars in business, science, engineering, and public policy at HKUST and the other universities work together to investigate the impact of environmental risk on financial market and the financing of green infrastructure, among other issues. Having discussed all these ambitious goals, we all understand that we cannot be achieved in isolation. To this end, we have joined force with both the public and the private sectors to innovate and to initiate action plans. Together with the Hong Kong government's Geotechnical Environmental Office and the Hong Kong Observatory, for example, our researchers and their counterparts from other universities are building the world's largest physical model to advance slope stabilization technologies, which will save many lives in landsliding. You will hear more about this in the afternoon. Our collaboration also extended beyond Hong Kong. Our Institute for Environment is now assisting the government of Hong Kong, Macau, and Guangdong in monitoring ozone in the air, on land, and at sea across the Great Bay Area. By collaborating with government and the other stakeholders, we strive to contribute at the policy level and help build a cleaner and a safer environment for people locally, regionally, and globally. In closing, I hope CARE2022 will inspire every one of us to innovate many more cutting-edge solutions that will shaping the future of our Hong Kong's response to the climate adaptations and the resilience. Thank you again for joining us, and I wish you all a very fruitful time over the next 3 days. Thank you.
Thank you, Professor Guo, for the warmest welcome to everyone here. Thank you. And ladies and gentlemen, in this morning's section, we're very honored to have a recorded speech by Professor Petteri TAALAS, Secretary General, World Meteorological Organization, WMO. Please enjoy.
Greetings from Geneva. Thanks for the invitation to address you, and I'm sorry that I cannot be physically with you, but I'm happy to deliver my intervention through this video. And we are talking about the climate adaptation. We all know that the negative trend in weather patterns will continue for the coming decades anyhow, and in 2060s we could see a phase out if we are successful with mitigation. And that means storms, flooding, drought, heat wave type of disasters. But one game we have already lost, and that's melting of glaciers and sea level rise. We have already such a high concentration of carbon dioxide, and it's still rising, that we will see the sea level rise and melting of glaciers to be continued for the coming hundreds of years anyhow. WMO is the UN Specialized Agency of Weather, Climate and Water, as you all know, and we are very much dealing with national meteorological and hydrological services, with academic institutions, and also with private sector nowadays. And we are, for example, hosting IPCC, and we are one of the key players inside the UN family to advise, for example, Secretary General Guterres on climate matters. And climate change is the biggest challenge for the mankind this century, and that was also confirmed by the World Economic Forum this June, where they estimated which are the biggest risks for the global economy for during the coming 10 years. And you can see that climate action failure is number one, and extreme weather events they are number two. This war in Ukraine is hopefully going to have only a small impact on 10-year scale. I hope that's a valid scheme. And then we have shown that the warming has continued, and we can see this kind of year-to-year variation, which is very much related to El Niño, La Niña variation. And for example, last year was La Niña year, actually a third such year in row, and that's why we saw this anomaly in the Pacific Ocean. But for example, the Eurasian continent has been warming much more than the global average. And we have stored more than 90% of the excess heat to ocean, and oceans have been warming, and that's giving more energy for tropical storms, and it's also enhancing evaporation, contributing to the flooding problem. And we just published the greenhouse gas report a few days ago, where we showed that in all of the key greenhouse gases, carbon dioxide, methane and nitrous oxide, we have again broken records, and in case of methane, we saw the biggest annual increase last year. That was the highest since '83 when we started this kind of reporting. An IPCC report is showing that we have seen an increase in flooding events worldwide. All these green symbols indicate areas where we have seen increase in flooding, and you can see, for example, that almost the whole Eurasian continent has seen increase in flooding events, and that's the case also for many other parts of the world. And we have seen also increase of drought events, and that's valid also for some parts of Eurasian continent, Africa, both Americas and Australia. And then one of the challenges, as I already said, is the melting of glaciers, and this melting of glaciers has been speeding up, and that's bad news when it comes to availability of freshwater resources to the rivers worldwide. And the next slide shows the ratio between freshwater in the rivers coming from rainfall and coming from cryosphere. And you can see that, for example, in Central Asia, largest fraction of the freshwater is coming from the melting of glaciers, and also a big fraction is coming, for example, to many Asian rivers. From Rocky Mountains, we have lots of rivers, water coming from to the U.S. rivers, and also in Latin America, the Andes melting is contributing to the amount of water in the rivers. Globally, it's still dominated by rainfall, but this component coming from glacier melting is also very important. And we have started reporting on the status of water resources, and here is water storage trend for the past 20 years, and all these brown and orange colors indicate decrease of water storages, and you can see it happening again in Eurasian continent largely, and parts of North America and parts of South America especially. And we have seen also increases in, for example, in some parts of Africa and some parts of both Americas. And one of the main concerns related to climate change is the question how to feed the growing global population. And if we go to 3 degrees warming, which is our pathway at the moment, hopefully we will go to lower numbers with successful mitigation. But in case of 3 degrees warming, we would lose a large fraction of the global food production capacity. And you can see lots of red areas which indicate the decrease. And then we have increases in the green areas, but those are not the most suitable areas for agricultural production. So as a net effect, we would lose the global food production capacity. And one problem besides greenhouse gas emissions is related to population growth. This is, of course, contributing to the victims of climate change, but it's also contributing to the consumers, and it's also contributing to the water resource demand. And here you can, on this map, you can see areas where both population growth and water availability is going to be a challenge. And it's lots of dark color in Africa, Middle East, and some parts of southwestern Asia. Sea level rise has been doubled during the past 20 years. It used to be about 2 millimeters per year. And recently we have seen numbers exceeding 4 millimeters per year. And there's a growing component coming from melting of Greenland and Antarctic glacier, where we have the biggest mass and biggest potential during the coming decades. IPCC published its 1.5 degree report already 4 years ago. And there they demonstrated that to reach 1.5 degrees warming, we should bend this emission growth curve in the coming this decade actually, and then be carbon neutral by 2050. And in Glasgow, the G7 and European Union countries made such commitments to keep it on that pathway. But unfortunately, some other countries were not able to do so. And at the moment, we are heading towards 2.5 to 3 degrees warming. No more towards 3 to 5 degrees, which was the worst case scenario from the previous IPCC report in 2014. So things have been happening, but we still have a major challenge ahead of us. And the most recent IPCC Working Group 3 report was demonstrating how to reduce the emissions, which are the most effective means, which is indicated by the length of these bars. And you can see that for solar and wind energy, they are very effective ways to mitigate, and they are also fairly cheap ways to mitigate. These colors indicate the price, and they are fairly low price means to be successful. Then we have also several high bars coming from the land use, both agriculture and forestry, and there's also big potential, but the means are more expensive. And then we have plenty of means in transport sector, which are these short blue bars in the lower part of the graph. Altogether, this means a lot, and there are also potential means in that sector. And finally, I'd like to say a few words about the key initiatives of WMO for the coming years, and also for the forthcoming COP27 meeting and UN Water Conference, and also other meetings, and of course COP28 next year. First, we got the mandate from Secretary General Guterres to prepare an action plan to get 100% coverage of early warning services. At the moment, only half of our members have proper early warning services in place, and we are supposed to improve the situation in the coming 5 years so that there would be 100% coverage of multi-hazard early warning services and also impact-based forecasting. Then we are proposing a new way to monitor greenhouse gas budgets, carbon dioxide, methane and nitrous oxide, to use ground-based satellite and modeling tools to simulate what's happening in real atmosphere. And finally, our third dream is that we should create a global climate modeling center where we would have the biggest possible supercomputing resources to be able to go to higher resolution of climate modeling. The current climate models are not able to describe, for example, the rainfall amounts in a proper way, extreme weather events a proper way, or melting of, for example, Antarctic glacier in a proper way, and that's very much needed to have more information on what's going to happen in the future. At the moment, the models are too coarse for such purposes. And this early warnings for all, we got the mandate from Secretary General Guterres last spring to prepare an action plan, and that's what we have done, and we expect to get support by the UNFCCC member countries in the coming weeks for that initiative. And globally, only half of our members have proper early warning services in place. It varies from region to region. For example, in Africa, it's only half, and the same is true for Oceania, whereas in Latin America and Europe, the ratio is a bit higher. And our plan is to transfer the good know-how of developed world and advanced med services to the rest of the countries. And besides investments in early warning service capacity, we have to invest in the basic infrastructures. For example, we have major gaps in the observing systems in Africa, Caribbean, Pacific Islands, and some parts of Latin America, and that's valid for these ground-based stations, and it's also valid for the balloon sounding stations. And if we don't get input data from those regions, the quality of early warning services is automatically poor. And then we also have to invest in hydrological observing systems and related services and better integration of meteorological and hydrological services at the national level. And we have been lucky to work as a joint venture between 10 UN agencies to prepare such an action plan, and we have been assisted by high-level panel consisting of heads of state, ministers, and other key players from various sectors. And then we have another initiative on carbon dioxide budget. We have problems with understanding of the sinks of carbon dioxide, for example, the forests, and we have also limitations in our understanding of sources of methane. And here you can see that in some areas of this carbon budget, for example, we have a good understanding, but especially this land sink of carbon dioxide has very high error bars, and by having this new mean, we could have better understanding what's happening in real atmosphere. And the idea is that we would use already existing global atmosphere watch station, where we have about 150 stations worldwide and some aircraft and vessel measurements. We have satellite programs from China, Japan, and USA, and soon a couple of Europeans. And we have also modeling and assimilation tools, and by doing so we could create a system to monitor what's happening in real atmosphere instead of relying on reporting of the countries. And our final dream is to improve this global climate modeling. This is estimation from IPCC, what may happen to soil moisture and rainfall in the future. And it's likely that these estimates contain fairly big errors, and the impacts of climate change, they are very much felt through water and also soil moisture, which is driving agriculture. And also these extreme weather events and melting of glaciers cannot be described in a proper way with the current climate models. And that's why we would like to create a center where we have big supercomputing resources and dozens of leading scientists to run such an exercise. We are elaborating that further, and we would like to come out with the concrete action plan during the coming months. So with these words, thanks for the opportunity to address you, and I would like to wish you a most successful adaptation meeting. Thank you.
Thank you very much. And upcoming next, we're also very honored to have the recorded speech by Professor Panmao ZHAI, co-chair, Working Group 1, Intergovernmental Panel on Climate Change, IPCC. Please enjoy.
Ladies and gentlemen, dear colleagues, I am glad to be invited to speak at Climate Adaptation and Resilience Conference of 2022. My topic today will focus on our understanding on climate change risks, especially for coastal cities like Hong Kong. My report is based on IPCC, the 6 assessment reports, and AR6 summary for urban policymakers recently released in COP27. Global surface temperature in the last decade was 1.1 degrees Celsius higher than 1850 to 1900, and the warming rate is unprecedented in the last 2,000 years. Each of the last 4 decades has been successfully warmer than any decade that preceded it since 1850. Our best estimate is that almost all of the observed warming results from the consequence of human activities, with greenhouse gas warming partly masked by aerosol cooling. Natural factors such as solar and volcanic activities, as well as internal climate variability, are taken into account, while natural variability does modulate human-driven climate change at the regional scale and at decadal scales. It has little effect on global warming at the centennial scale. Recent changes in the climate are widespread, rapid, and intensifying. The atmosphere is warming and getting wetter. There are shifts in the large-scale atmospheric circulation. In the cryosphere, widespread loss of snow and ice has been observed. The ocean is warming, with more frequent marine heat waves and changing in multiple ways. As a result, the geographic range of many marine species is shifting. Due to loss of land ice and ocean thermal expansion, sea level is rising at an accelerating rate, now reaching 3.7 millimeters per year. Over land, surface air temperature are rising faster over land than the global average. Climate zones are shifting polarwards, and the growing season length in much of the northern hemisphere tropics has increased. All these observed widespread changes are attributable to human influence. Human-induced climate change is increasingly affecting every region and system of the world, including through more intense weather and climate extremes. In these two maps, we can see in all the regions with sufficient data, there hot extremes have precipitation events increasing, especially in East Asia. The future warming depends on emission scenarios. Our best estimate is that global surface temperature, when averaged over 20 years, it will reach 1.5 degrees Celsius in the period of 2021 to 2040. This implies that by 2030, every single year has a 50% chance of having annual global surface temperature above 1.5 degrees Celsius. Only under very low and low emission scenarios, global surface temperature is projected to be limited below 2 degrees Celsius. For the intermediate scenario, our best estimate is that global surface temperature will reach 2 degrees Celsius in around 2050, around about 2.7 degrees Celsius by 2100, and by 3.3 degrees Celsius by 2300. The global warming of 1.5 degrees Celsius and 2 degrees Celsius will be exceeded during the 21st century unless deep reduction CO2 and other greenhouse gas emissions occur in the coming decades. Continued global warming is projected to further intensify global water cycle, including its variability, global monsoon precipitation, and the severity of wet and dry events. Many changes in the climate system become larger in direct relation to increasing global warming. The intensity and the frequency of hot extremes and marine heat waves is expected to increase, and the heavy precipitation will increase 7% per degree Celsius warming, and the drought in some regions and the proportion of intense tropical cyclone are expected to increase. Every region will experience concurrent and multiple changes in climatic impact drivers at higher levels of global warming. In many places, they are causing compound impacts. As global surface temperature increases, warming is expected larger over land and in the Arctic, and amplified in the cities. Most cities and urban areas will experience increases in local temperature of 1.5 degrees Celsius and 2 degrees Celsius much earlier than other areas. Heavy precipitation events are more intense and more frequent in a warming world, and the runoff is amplified by urbanization. Heavy precipitation events can flood buildings, roadways, subtunnels. Heavy precipitation may overwhelm city transportation and storm water drainage systems, which are typically not designed for exacerbated extreme rainfall events. With very high vulnerability, low-lying islands and coasts, especially the island and the coastal cities, are facing accelerating sea level rise. The extreme events occurring today, such as storms, tropical cyclones, droughts, and increasing marine heat waves. These risks are all highly related to climate warming levels. Due to the projected global mean sea level rise, local extreme sea levels that historically occurred once per century are projected to become at least annual events at most locations in 21st century. Impacts can continue to increase with rising frequency of such historical centennial events. The extreme sea level increased by both sea level rise and storm surge, and extreme rainfall river flow events will increase coastal flooding with potential risk for widespread mortality and damage to housing, transportation, and energy infrastructure. The combination of future urban development and increasing frequent extreme climate events, such as heat waves, will exacerbate risks for heat stress in cities. In the future, urbanization will intensify urban heat island effects regardless of changes in the background climate. The science is clear that cities and urban areas are not only facing increasing climate change risks, but also the main sources of climate forces, as well as sites of innovation and the implementation of adaptation, mitigation, and sustainable development. The global community has a map of the solution space on climate change and sustainable development, with cities playing a central role in how we adapt and mitigate climate changes and develop climate resilience. Our climate resilient future will be the reduced climate risks through adaptation, the reduced greenhouse gas emission through mitigation, and the enhanced biodiversity, and achieved the sustainable development goals. With increasing warming, the window for higher climate resilient development opportunities is closing. Starting today, every action, every decision matters. Worldwide action today is more urgent than previous assessed. Future changes to our climate and how they affect us depend on choices we make in our cities and urban areas today. Our climate is our future. Ladies and gentlemen, dear colleagues, there have been major advances in climate change science globally. This is science. Our knowledge of current trends and our understanding of future changes are also part of the solutions. It is crucial that they are considered in adaptation strategies, mitigation measures, and resilience development. Today, we have much more precise and clearer picture of how the climate system works, how climate change influences our cities. Dear colleagues, it is essential that this knowledge is embraced as integral to the ongoing talks about our future actions as we collectively prepare for more frequent, more intense, and new types of extremes and novel climate conditions. I wish you a successful conference. Thank you so much.
Thank you very much. And next, we will continue our program with the latest update on climate change impacts to Hong Kong. And to present this, please join me in welcoming Dr. CHENG Cho Ming, JP, Director of the Hong Kong Observatory, to the stage. Dr. Cheng, please.
Good morning and welcome to all. Just now, Professor TAALAS and also Professor ZHAI has given us a clear picture about the global climate change situation. And today, I'll talk a little bit about the latest update on the climate change impacts to Hong Kong. But before I start, I also would like to spend a few minutes on the global situation. I think as we all know that the climate change is caused by the emission of greenhouse gases to the atmosphere. And this picture shows the situation in the past. And we can see that even though we have a COVID-19 situation in the past couple of years, and we also observe a dip in the overall carbon dioxide emissions. But after that, in recent years, we are seeing that the carbon emission already rebound. And if you look at the overall carbon dioxide concentration in the atmosphere, we are seeing that other than seasonal changes, on the whole, we are seeing year on year, we are still observing increasing carbon dioxide concentration in the atmosphere. So bear in mind that we want to have carbon neutrality, but reality is that we are still pumping carbon dioxide into the atmosphere, making the carbon dioxide concentration still on the rise. And I think just now you have already seen this picture. This is the global mean surface temperature. And we are seeing that in 2021, we are already around 1.1 degrees above the industrial level. Bear in mind that in the Paris Agreement, we want to limit the temperature rise by no more than 1.5 degrees from the pre-industrial level. And if that's not possible, at least we want to limit it to within 2 degrees. And the situation now is that we are already 1.1 degrees. So it's not too far from 1.5 and also 2 degrees. And if you look at the sea level rise, just now Professor ZHAI already mentioned about this. The sea level rise, the rate of increase is already accelerating. And the latest figures from the recent years is that we have around about 3.7 millimeters of increase per year. And this is also the situation observed from the satellite observation. And we are saying that the global sea level rise since the 19th century, 1900, was unprecedented in at least the last 3,000 years. So the current level is very, very high. And also from the AR6 report, it is mentioned that in the future, we will be expecting the sea level continuing to rise, even though we are able to achieve carbon neutrality mid-century. And if you look at the impact of tropical cyclones, I think since Hong Kong is in the coastal region, we are more affected by tropical cyclone every year. And we observe that the global proportion of major tropical cyclone, meaning super typhoons, their occurrence has increased in the last 4 decades. I remember when I first joined the observatory, we do not often encounter super typhoon, but in recent years, it is more commonplace. It's really true that the proportion of a major tropical cyclone has already increased. And with a major tropical cyclone more, we are seeing that the average and also the maximum rain rate associated with tropical cyclone has also increased. That means it will bring more water, it will bring more rainfall, and also cause severe flooding to our region. Another thing is that seems it's not working. Okay. The proportion and also the intensity of the most intense tropical cyclone are projected to increase in the future. So what it means is that the storm surge will increase in terms of frequency and also the extent, and also the precipitation rate will increase. And so the two together means that we'll be ending up having a compound effect from hazards like storm surge, flooding the area, and also more precipitation, also causing severe flooding. This is the sea level rise This is the temperature change in Hong Kong. So back to the situation in Hong Kong. I think we all understand that these few years we are seeing the temperature in Hong Kong rising. And in fact, if you look at some statistics, here on the right-hand side, you can see the number of hot nights, okay? And number of hot nights means that the minimum temperature throughout the day will be at 28 degrees or more. So you feel it's very hot throughout the day. And the number of hot nights in the past, from the figure between 1885 to 1914, the average figure is just 0.6 day per year. But now, in the past 30 years, 1992 to 2021, it has already increased 42 times to 25 days per year. And just this year, 2022, we have 52 days. Is already double the average figure in the past 30 years. And if you look at the red one, the very hot days, which means the maximum temperature during the day will be at 33 degrees or more. So back to 1883 to 1914, we have 2.2 days per year. And it has increased 9 times to 18.9 days between 1992 and 2021. And this year, we already have 52 days. And on the last column, the blue one, on the table, the last column, which shows the number of days with maximum temperature at 35 degrees or more. So back in 1885 to 1914, the average figure is 0.07 days in a year. And it has increased 30 times to 0.9 days within the period 1992 to 2021. And this year, we already have 15 days. And I think you also recall that in July, which happened to be the warmest month ever recorded in Hong Kong, we have 10 days of temperature at or above 35 degrees. So this shows that warming is actually happening. And if you look at the annual rainfall, on the left-hand side, we are seeing that there's a slight increasing trend in terms of the annual rainfall, although there are significant year-to-year variation. And on the right-hand side, which shows the short-term rainfall, which is the maximum instantaneous rainfall that is recorded at the Hong Kong Observatory. And we're seeing that this record has been broken multiple times in the past. And with global warming, we expect that it may be broken anytime. So to project what's in the future, I think you've already seen that in the presentation by Professor ZHAI. We have 5 different scenarios given by IPCC, which correspond to very high greenhouse gas emission all the way to very low greenhouse gas emission. For the very high greenhouse gas emission, it means that the carbon dioxide emission will double the current level by mid-century. And for intermediate, it means that the carbon dioxide emission level will remain more or less the same until the mid-century. And of course, we try to achieve much better than that. In the low greenhouse gas emission scenario, is that the carbon dioxide emission will decline to net zero after 2050, and then followed by net negative carbon emission. And then for the very low one, which is more ideal, is that we'll be able to achieve net zero around 2050, followed by net negative carbon emission. So this is the projected, not the carbon dioxide and also greenhouse gas emission scenario corresponding to the 5 scenarios just shown. And from IPCC, they have an interactive atlas that give us the projection, the data from grid points around Hong Kong and around the world as well. So we are able to get those data to generate a projection for Hong Kong. And here is the figure on the annual maximum temperature for Hong Kong relative to the mean from 1995 to 2040. And you can see that in general, the annual maximum temperature expected to rise throughout the century. And then until the end of the century, it will be around 2 degrees above the level between 1995 to 2014. And in case we are heading towards the very high greenhouse gas emission scenario, then of course the temperature rise will be much more. By the end of the century, it will be hitting about 4 degrees. And here's the projection for hot nights, very hot days, and also cold days. And for the yellow one, which is the hot nights, we are saying that by the end of the century, we may be expecting around close to 120 days with hot nights for the intermediate greenhouse gas emission scenario. So think about it, 120 days, which is more about around about 3 to 4 months. So it's a very, very long duration with hot nights. And also for very hot days, it will also increase close to 100. But cold days will decrease to single digit by the end of the century. And as comparison, for the very high greenhouse gas emission scenario, the projection is even higher for hot nights and also very hot days, but lower for the cold days. And this is the projected annual maximum daily rainfall for Hong Kong as compared with the level between 1995 to 2014. And you are seeing that on the left-hand side for the intermediate greenhouse gas emission, we are seeing the projected value to increase. By the end of the century, it will be close to 16 to 17% higher than the level at 1995 to 2014. And then for the very high greenhouse gas emission on the right, the increase will be much more, close to 30%. And for the sea level rise, just now we are expecting that the sea level to continue to rise in the future. And we've got the projected data from IPCC and also NASA. They have a website. And here is the projection for Hong Kong. Actually, the level here for Hong Kong is very close to the global level. And on the left-hand side, the chart in the middle, you can see that we have 5 projected ranges, which correspond to the likely range that is expected for these 5 scenarios. And you can see that whatever scenario, the level of sea is expected to rise. And in fact, in the AR6 report, it is said that the sea level will continue to rise for the coming decades, for the coming even millennia, for all the emission scenario. So it is basically depends on us how to limit the emission of the carbon dioxide to reduce its level of sea level rise. And here is the projection on tropical cyclone activities in the Western North Pacific. So if the global temperature increased by 2 degrees, so we're expecting that the TC intensity, the tropical cyclone intensity, to increase around about 4 to 6%. And also for the proportion of very intense tropical cyclone, it will also be increased by around about 10%. And for TC precipitation, will increase by around about 15 to 20%. And the impact is that I think we all experienced this in 2018 when Mangkhut hit us, and we have severe flooding owing to the storm surge, and also the high wind will also bring some damages. So this is a short summary. Under climate change in Hong Kong, we will be expecting more very hot days, hot nights, but less cold days, and the temperature will continue to rise. And heavy precipitation will be more frequent, and also the proportion of tropical cyclone, a more intense tropical cyclone will be more. And as a result, the mean sea level continue to rise. We will be expecting the risk of storm surge will also continue to rise. And lastly, I would like to relay the message from the UN Secretary General. We said that we are now on the highway to climate hell with our foot on the accelerator. So we are now not just climate change, we are actually seeing the climate crisis. So that's something that we need to do. And it also said very clearly that any hope of limiting climate rise to 1.5 degrees means that we have to achieve the global net zero emission by mid-century. So we are getting dangerously close to the point of no return. So we need to do something very quick and globally and large extent. And lastly, it says that humanity has a choice, cooperate or perish. So that concludes my presentation. Thank you very much.
Thank you, Dr. Chang. Please remain on stage and be seated. And may we now invite Mr. Ken C K Yeung, SPS, FR Maths, former director of the Hong Kong Observatory, joining us on the stage for the upcoming Q&A section. Mr. Chen, please. And now we will have a Q&A section. For those who have questions for Dr. Chang and Mr. Chen, please raise your hand. And when the moderator invites you for the question, please proceed to one of the mic on the side of the theater.
Yes, seems a rather gloomy picture, right? So before I invite the first question, maybe just a question for my successor.
Oh. Okay.
I have issued 3 number 10 signals, but you haven't yet issued one. So what's your outlook?
It really depends on the actual track of the tropical cyclone in the end. But under climate change, as I mentioned before, the proportion of intense tropical cyclone will be more in the future. And also the second thing is that the risk of tropical cyclone hitting anywhere, of course, it depends on the eventual path. But with more tropical cyclone going more intense, so I think chances that we maybe end up having more number 10 signal in the future.
Great. I think it's good news for our students here. So any questions from our audience, especially our future generation? Anyone? Yes, please. You have the microphone.
How can we?
Yes, please.
Yeah.
We can hear you.
How can we?
Oh, take your time.
How can we use current technology to reduce the impacts of extreme weather?
Okay.
Thank you.
Very good question indeed. I think that there are many ways that we can face this question. But for me, especially, well, in my role as the director of the Hong Kong Observatory, I think especially in the meteorological community, I think first of all, we need to do much better in monitoring and also warning these kind of extreme weather. For us, in the past, I think we've been issuing forecasts and also warning based on what we call deterministic forecast, meaning that we think that something will happen or not happen. Okay, when it happens, we forecast it and also we issue a warning. But I think this has already been changing over time. In recent years, we are more on a probabilistic forecast because anything is attached a certain degree of probability. So nowadays, we will not just use one single deterministic model or forecast. We'll also use what we call the ensemble forecast. That means that the same model will be running many, many times using slightly different, what we call initial condition, trying to grasp as much more information about the future evolution of the weather as much as possible. And then from that, we can look at the probability of something that may happen. And in fact, quite a number of things. One thing that is already being done at the observatory is to assess the chance of time signals. Of course, that will take some time. But of course, the idea is that if we have multiple computer models, results, then that may be able for us to assess the chance that the tropical cyclone signal will be affecting Hong Kong. That's one thing. Another thing, more about the rainfall, because just now we mentioned about the chances that with climate change, we'll be expecting the rainfall in the future will be more intense. That means the chance of a rainstorm will be higher. And using the same method based on these ensemble forecasts, and also some of the, what we call the nowcasting technique, we are now trying to assess the probability of having heavy rain on the next day. So this is something that we are trying to do, hoping that it will give us more confidence on what may be likely to happen in the future as a way to allow people to better prepare for any severe weather to come.
Thank you. So I think probabilities is that we will be in a better position to address our risk in climate change. So I think we are almost tea break, so maybe I invite one more question from the audience. Anyone? Please.
Thank you. So Mr. Zheng mentioned, showed a figure. It shows that the extreme precipitation recorded in Hong Kong is about 150 millimeter.
Yeah.
But last year in Zhengzhou, it recorded more than 200 millimeter for 1 hour.
Yeah.
So I wonder if climate change is making that also likely to happen in Hong Kong. And is the city ready for that?
Okay.
Thank you.
Okay, good question. Firstly, some figures. Yes, for Zhengzhou that you mentioned, for the rainstorm in China, the hourly rainfall is around about 200 millimeters in just 1 hour. At the Hong Kong Observatory, the record is 145.5. So still some slight margin. But as I mentioned before, with global warming, we don't know. Maybe this can be achieved very shortly in the future as well. We don't know. But the second thing is that the impact on Zhengzhou and also the impact on Hong Kong can be vastly different. Firstly, because Zhengzhou is an inland city. So also, if you look at its annual rainfall amount, it's around about 640 millimeters in a year. But for Hong Kong, it's 2,400. So in Hong Kong, basically the infrastructure is that it will be at least able to handle such amount of rainfall. But for Zhengzhou, it's not. So when extreme rainfall happened there, so the infrastructure there is not able to handle such a large amount of rainfall. And also in Hong Kong, because we are in a coastal region, so when the rain can easily drain away and then into the sea. And secondly, in Hong Kong, we also have an underground water tank, which is able to at least temporarily hold some water so as to alleviate the degree of flooding on the ground surface. But I think, yes, when the rainfall become heavier, of course, this will be a challenge for us to handle such situation in the future.
Yes, and we will hear more in the panel discussion after the break. And of course, welcome to the workshops in the afternoon, where we will have more detailed discussion on these topics. So I think at this point, we will have the break for now, and then we will resume at 10:30. Thank you very much.
Thank you. Thank you, Dr. Chen and Mr. Sum, for the valuable insights. Thank you. Please be seated. And now we will have a short break. Our program will continue at 10:30 a.m. We have a backdrop of the conference outside the auditorium. Please feel free to take photos and share them on LinkedIn and Facebook using the hashtag CARE2022. See you all very soon. Welcome back, everyone. We're very honored today to have lots of very important people joining us today at this conference, including government officials, HKUST representatives, sponsors, and supporting organizations. And to remember this special moment, we will now have a group photo-taking time on the stage. We will now put our hands together and invite Professor Yike, Provost. Thank you all the guests. Thank you very much. Please be seated. Thank you. And let's put our hands together again to thank all our guests joining us today in the conference. Thank you. And next, let's take a mass photo together to include every one of you in this auditorium together. Our photographer will be taking the photos on the stage. Please smile at the camera, and when our camera is ready, our photographer is going to take lots of nice photos of everyone here. Let's find a perfect spot. So everyone, please look at the camera and the stage. Keep smiling. Make sure you can look at the camera so that the camera can look at you. May I also have your thumbs up and wishing this conference a success. Keep smiling. Thank you very much. Please give a big round of applause to yourself as well. Thank you all for today for your kind support. And thank you, and please enjoy the rest of the program. And upcoming next, for the morning plenaries, we will have the presentation on nexus between mitigation and adaptation, following by the presentations and discussion with the heads of government departments on Hong Kong's climate adaptation. Then we will have a lunch break at 12:30 p.m. and our conference will continue at 2 p.m. There will be 2 concurrent afternoon workshops aiming to let participants go deeper of the needs and efforts in Hong Kong and bringing adaptation and mitigation issues together. And there will be 2 workshops. Let me introduce you the workshops details. For workshop A, we'll have the topic Major Government Plans, reflecting on climate change policies, adaptation and mitigation, risk and finance at LTJ. And also, workshop B, with the topic Preparedness and Resilience, emergencies, security, health, water, heat stress, and regional collaboration at LTE. And you can always refer to our website for the workshop details and its respective locations. There are also a map on your badge, and you can scan the QR code for more details. And now, without further ado, we will have the presentation on nexus between mitigation and adaptation. May we have the presence to the stage, Mr. ZHAI Chin-wan, BBS JP, Secretary for Environment and Ecology, to share with us the topic of striving towards carbon neutrality. Mr. ZHAI, please.
Professor Kwok, Christine, Alexis, friends and colleagues, ladies and gentlemen, good morning. It is my honor to be given a chance to share with you the government's policy on carbon neutrality. Just 2 years ago, President Xi made a statement at the general debate of the United Nations General Assembly that China will scale up its intended nationally determined contributions by adopting more vigorous policies and measures. We aim to have CO2 emissions peak before 2030 and achieve carbon neutrality before 2060. For Hong Kong, we have also set a target. Our target is to achieve carbon neutrality before 2050. Actually, our carbon emissions already peaked in around 2014. And compared to 2014, the carbon emissions in Hong Kong today has reduced about by 1/4. And therefore, we have set an interim target to reduce our carbons by half before 2035. And then our carbon neutrality towards 2050. In order to achieve these targets, the Chief Executive has set up a steering committee, pulling all policy secretaries and relevant department heads together in order to have a whole government approach to tackle the issue and to achieve the objective. On the financial side, Hong Kong government is also prepared to spend 240 billion in the next 15 to 20 years in order to support various mitigation and adaptation measures. In order to deal with carbon, in order to achieve carbon neutrality net zero before 2050, we need to look at the sources of carbon emissions in Hong Kong. Based on the 2020 statistics, about 60% of the carbon emissions in Hong Kong is due to electricity generation, and about 20% is due to transport, and about 9 or 8% of the carbon emissions are from our landfills. You may wonder why our landfill will emit carbon. It's because when those garbage, those rubbish buried in the landfill, they will decay and emit methane. And methane is a very strong greenhouse gas. And therefore, it's also one of the priority areas that we need to work on. And therefore, based on all this, we have set a 4-pronged strategy to deal with carbon emissions in Hong Kong. First is that we need to achieve net zero electricity generation. We need to find technologies or methods to turn our electricity generation into a mode which will emit no carbon. And also because in Hong Kong, 90% of the electricity is consumed by buildings. We believe it is necessary for us to promote energy saving as well as green buildings, which will help us not only to reduce carbon emissions, but also to help us to lower, to minimize the capital cost required for the green transformation. And also we need to promote green transport. And lastly, we need to deal with waste reduction. We need to find a way to stop landfilling. In terms of a net zero electricity generation, Hong Kong, we have already stopped building new coal-fired power plants since 1997. In order to further reduce the using of coal, we have set a timeline, a target, to cease using coal before 2035. And then we aim to increase the use of renewable energy to about 7.5 to 10% before 2035, and then we'll increase it to 15% subsequently. You may wonder why, 7.5 or 10%, it looks very small. But indeed, if you go to the new territories, you can see that many village houses has already installed solar panels on their rooftops. But all those solar panels were acting together. It contributes to less than 1% of the electricity demand in Hong Kong because of our density and because of our very small city. And therefore, we do not have a lot of room to use renewable energy. And therefore, when we are talking about 7.5 to 10%, we are already talking about a 10-fold increase in renewable energy in this city. It's challenging, it's difficult, but we believe we must increase its use. And then we need to look to other zero carbon energy. And for example, hydrogen. For example, working with our neighbors in order to explore, to develop more zero carbon electricity. And that's something we need to do in order to achieve net zero carbon emissions before 2050. And also for electricity saving, we need to promote green building, as well as to set energy saving targets for residential buildings and for commercial buildings. And I believe my colleagues will elaborate on that more, and therefore I can go quickly on them. And on green transport, many of you may be aware that we are promoting the use of electric cars in this city. And somehow, I think the pickup rate is quite good. As for now, for the newly registered private cars in Hong Kong, 1 out of 2, that means half of the new cars in Hong Kong are electricity vehicles. This picking up rate, I think is the highest in Asia. And as far as I know, probably the second in the world. Yeah. And also, 2 years afterwards, we'll put up a roadmap for commercial vehicles. And we have to set a target before 2027. We need to push to put forward 700 electric buses and 3,000 electric taxis in this city. And towards 2035, we will cease registration of new fuel-propelled and hybrid private cars. And we aim at before 2050, we will be able to transform the transport sector into a zero carbon emission sector. And also, we plan to test the use of hydrogen vehicles next year, as well as to promote other new energy transports, for example, electric ferries. Okay, on waste reduction, and in order to reduce waste, we'll implement solid waste charging next year, as well as we will speed up to the control and phasing out of disposable plastic tableware in phases, and we will stop landfilling of waste and develop more waste-to-energy facilities. Our target is to stop landfilling before 2035. And so that the entire waste sector will be able to achieve carbon neutrality before 2050. On resilience, I've mentioned that the Chief Executive is setting up a steering committee to pull together all the bureaus and secretaries in order to tackle the climate change issue. And under that steering committee, there's a working group led by the civil engineering and led by the Civil Engineering Development Department. And in order to review the infrastructure for Hong Kong to see whether they can stand for the extreme weather, for example, extreme heat, very strong typhoons, and also the sea level rise. And they will derive a new infrastructure standards for Hong Kong. And also there's another contingency plan to deal with natural disasters, because no matter how hard we are, we work, we believe disasters will happen in Hong Kong, and therefore we have a contingency plan. And there's an interdepartmental steering committee chaired by the Chief Secretary to coordinate all the actions required to deal with all those disasters. Yeah. And also, I think the recently, the COP27 has reinforced that the need to limit the global average temperature increase to less than 1.5 degrees Celsius. And therefore, our commitment is towards striving to achieve carbon neutrality before 2050, as well as we need to halve our carbon emissions by before 2035. And in order to do that, we will accelerate the phasing down of coal and also transition to a renewable energy. And we need to focus more on adaptation. I've mentioned that the government, we have taken up a working group to look into the various design standards. And also we have to work with our neighbors in the Greater Bay Area. We'll be set up a super site on air quality laboratory and also meteorological monitoring. And that will help us to enhance our capability to deal with our change in weather and also the climate change. And also we need to invite more people, young people to join with the team. And therefore, in our new council for carbon neutrality and sustainable development to be set up, we'll enhance the participation of youth. We'll set up a youth committee in order to embrace young people into the process. And that is what we are doing in order to tackle the climate change challenge. And subsequently, I think my colleagues in different bureaus and departments will tell you a lot more about what the precise work they are doing and they will do in order to tackle the problem. Well, thank you.
Thank you, Mr. Zhe. Please be seated. Next, may we have the presence to the stage, Mr. LAM Chi Man, David, JP, Under-Secretary for Development, for his presentation on nexus between mitigation and adaptation. Mr. Lam, please.
Professor Kwok, Professor Loh, Professor Lau, Secretary Zhe, distinguished guests, good morning. I'm very honored to be invited here today. Thanks for Hong Kong UST for setting up this platform, converging government officials, academia, private sector, and public bodies for knowledge exchange and sharing on the latest climate adaptation and resilience effort. Nowadays, climate change is an issue so popular that not only arouses the attention of government and scientists, but also everyone. Extreme weather events has become more frequent and impact more on our daily lives. The increased number of very hot days, which we witnessed in the past few years, more extreme rainfall, rising sea level, increased intensity of tropical cyclone, and more severe storm surge. Hong Kong is of no exception. All of us should still remember the attack of the super typhoon Mangkhut in 2018. The government has been attaching great importance in combating extreme weather, where the whole of the government approach is at the heart of our work. Secretary Zhe just mentioned that the government has been doing a lot on mitigation, including setting the 4 ambitious decarbonization strategies and establishing the Steering Committee on Climate Change and Carbon Neutrality, striving to achieve carbon neutrality in 2050. We should also spend no efforts in decarbonize and build a low-carbon livable communities. On the other hand, we should not overlook the need for adaptation, which should be considered together with mitigations. The government has been laying equal importance in planning ahead and implementing our adaptation work to make our homeland in response to climate change. In land supply, you may have heard about, we always talking about enhancing speed and efficiency, quantity and quality. Maybe I can also introduce our adaptation works from that perspective. For speed and efficiency, Hong Kong, being a coastal city, is susceptible to heavy rainfall and tropical cyclone attack. The Climate Change Working Group on Infrastructure, in short CCWGI, tapped expertise from various works departments and the Hong Kong Observatory to work together coherently, attaining synergy and efficiency. Since the promulgation of the IPCC Safe Assessment Report in 2021, the CCWGI has promptly assessed the climate change projection parameters for Hong Kong, and then update the 2 relevant design manuals for port works and stormwater facilities to reflect the latest projection of sea level rise, extreme wind increase, etc., and spearhead departments for planning for more resilient government infrastructure. We will continue the initiative like the Blue-Green Coastal Line, flood attenuation measures, coastal enhancement, and landslip preventive measure. Maybe I can also present you some number to show the works of the government's adaptation works. Slope enhancement works are something may not be so noticeable, but very essential. So you may find the government, the civil engineering departments has done a lot of government dynamic slope improvement works. And also our drainage services department has also do a very, very long drainage improvement works. And they have also completed 4 stormwater storage tanks in various parts in Hong Kong, and some more is in the pipeline. On top of that, we are also seeking funding approval to build the Hong Kong First Barrage in Yuen Long to protect the lower lying area from flooding during heavy rainfall. And we have also assessed and identified 26 residential areas for coastal enhancement, like LEUNG and Hang Fa Tsuen, which are vulnerable to storm surge, and to formulate plans and measures to protect them during heavy rainfalls. And we have also identified over 350 government critical infrastructure and formulate a package of measures to ensure that they will function normally during extreme weather. And for our water supply, we got 5 diversified sources of water security. For the later 2, the desalination of seawater into potable or drinkable one, we are now building a desalination plant in Tseung Kwan O. And for recycled water, in planning for our new development areas in new territories, we will plan to reuse our wastewater and treat them so that they can use for flushing or other non-portable purpose. Our director of departments should talk more about these projects in their presentation later on, so don't miss them. For quality, I think we should also see how we can attain more quality planning and more quality infrastructure. This is not only adapt, but also mitigate climate change. When talking about quality infrastructure, we will adopt smart, green, and resilient city strategy, particularly in planning for the new development area, just like those in New Territory, the Northern Metropolis, or in our proposed Gaoyizhou artificial island. Maybe I can just to name a few of this SGR city strategy. In planning for the new development area, we will adopt the planning concept of 15-minute neighborhood city. That is, a resident can reach their daily necessity, be it transport facilities, healthcare, shopping, school, within their walking distance, so that we can promote more healthier life and also reduce carbon emission. We will also encourage more greener and more sustainable building through our certification system under the BEAM. We will also encourage the use of electric vehicles by installing charging facilities network. In reclamation projects, we have been conducting trials on application of eco-shoreline to enhance marine biodiversity and promote sustainable coastal development, like in the case of Dongchong Liutang extension. We will also adopt the concept of river in the city to revitalizing the concrete loader in the city into river environment, enabling the public to enjoy the more vibrant river facilities. One of the projects we are pursuing is to revitalize the one in Yunlong Liutang. In the long run, we shall embrace the climate challenge with sustainable and progressive effort, while at the same time achieving carbon neutrality. I think Hong Kong has many good stories to tell, including the climate adaptation and resilience efforts and our world-class infrastructure. I encourage you all at climate adaptation industry sector leaders to help tell the good story to the world of Hong Kong and let our city shine in the world. I wish the conference every success and you all have a fruitful event. Thank you.
Thank you. Thank you, Mr. Lam and Mr. Zhe, for bringing us the nexus between mitigation and adaptation. For the next program, we are very honored to have various presentations on Hong Kong's climate adaptation by heads of government departments. May we now invite Professor Christine Low, SBS JP OBE, Chief Development Strategist, Hong Kong UST Institute for the Environment, to moderate this section. Please give a big round of applause to Professor Low.
Good morning. Well, thank you very much for being here. And I think you've just heard the two secretaries explain to us many broad plans. And it is very extraordinary today that we have on the same stage the head of climate and environmental policy together with the Undersecretary for Development. What I want to just stress here is the two bureaus need to work very closely together so that the mitigation, decarbonization plans actually takes place with the planning of enormous infrastructure that is still happening in Hong Kong. Now, I am privileged to now present to you a number of senior government representatives who will give you more details about what Undersecretary Lam has just shared with us. And then in the afternoon at the workshop, we will drill down on some of these plans even further. So without further ado, I would like to invite Ricky Wong, who's the head of the Civil Engineering Office, to come and share a deeper plan of the coordination work within the government. Ricky, please.
Professor Grout, Professor Low, Mr. C.M. Shun, Professor Alice Lam, Mr. C.W. Chair, and Mr. David Lam. Honorable guests and speakers, good morning. I could not think of a more timely and pressing juncture to organize today's forum right after the COP27 held in Egypt 1 month ago. I am pleased to share CEDD's experiences and our future journey on carbon neutral communities and concerning climate resilient infrastructure for tomorrow. My presentation will be divided into 4 parts. This is the background. We are well aware of the unique challenges of Hong Kong, including Hong Kong's space constraint and densely populated nature. Hong Kong is prone to extreme weather as a coastal city, and the need for advancement in decarbonization technology in the pursuit of carbon neutrality before 2050, and the need for participation from all the society. We engineers should turn the challenges into opportunities. We have stick on the 4 decarbonization strategy as mentioned by Secretary just now, including net zero electricity generation, energy saving and green buildings, green transport, and waste reduction. With sound government's infrastructure planning, we are able to contribute to decarbonization and to enhance infrastructure's adaptation and resilience. In particular, in the planning and design, the Lantau Tomorrow vision and New Territory North. In a nutshell, as to climate mitigation, CEDD is moving towards net zero carbon development in the 2 strategic growth areas, SGAs. There is the Gaoyizhou Artificial Island in the Lantau Tomorrow vision, and the New Territory North. They are the main drivers to spearhead greenhouse gas reduction. CEDD also leads the Climate Change Working Group on Infrastructure, CCWGI, to press ahead the government effort in relation to climate adaptation infrastructure resilience, including, first, review all the performance of the critical infrastructure under extreme weathers. Second, to update our design manuals. Third, to carry out climate change studies. And fourth, to strengthen our coastal infrastructures. Having a very different advantage of being on a new and large piece of land, the SGAs are suitable for adopting forward-looking and sustainable smart and green infrastructure system, planning for convenience and resilient land use, enhancing energy performance, promoting urban forestry, making use underground space, incorporating sustainable urban drainage and coastal protection systems are examples to make the city smarter, greener, and more resilient. The Smart, Green, and Resilient strategy echoes the theme of achieving climate mitigation and adaptation. The 2 SGAs are envisaged to be carbon neutral communities. Let me share with you some of our initiatives. To resonate the decarbonization of green transport, the 2 SGAs will adopt transit-oriented development mode in town planning, in which railways will serve as a backbone of transport. We encourage the active use of non-motorized transport mode, including walking and cycling. Pedestrian-friendly environment will be created, such as car-free zone and covered walkway. We shall also instill a 15-minute neighborhood urban development concept where people can meet most of their daily lives within a short distance. The use of electric vehicles has become more popular. To support wider use of electric vehicles and to prepare for the phasing out of conventional petrol cars, we plan to provide sufficient electric vehicle charging facilities. Hydrogen fuel cell electric car is an alternative. The setting up of necessary infrastructure, such as a hydrogen fueling station, will be explored. We shall also explore to develop a shared mobility on demand, integrating with smart technologies. We will also look into the possible use of autonomous vehicles with the corresponding infrastructure provision to provide sufficient bandwidth for data transfer. To echo with the decarbonization strategy of energy saving, we also plan to adopt a district cooling system This is a large-scale and centralized air conditioning systems having 35% less electricity consumption as compared with traditional air-cooled systems. We will apply the common utility tunnels to organize underground utilities in a more systematic manner to minimize the need of road opening. We also want to reduce energy demand in buildings with mandatory guidelines like Building Energy Code and fulfill voluntary green building labeling scheme like Green Plus. Modular integrated construction method, as well as low carbon construction material, will be used as far as possible. We also want to explore the single-site multiple use model, using a gray space for greening and rooftop for recreational use, while placing a transport interchange hub within the commercial and residential developments. We will include urban forestry strategy to provide pleasing landscape and help moderate heat island effect. Cohering with decarbonization strategy of waste reduction, we will study the use of waste-to-energy facilities to promote circular economy. We also want to explore the waste separation and collection facilities and resources recovery facilities to reduce the quantity of waste disposal at landfill. Nowadays in Hong Kong, PV panel system is a common type of renewable energy source. In addition to PV panels, bearing in mind the strategy of net zero electricity generation, we will further explore the opportunities of other on-site renewable energy sources such as wind farm, tidal turbine, and biomass. What I've just mentioned relate more to climate mitigation. How can we strengthen our infrastructure to adapt to the effect of climate change and to make our city more climate resilient? The government attaches great importance to combating climate change. The High-Level Steering Committee on Climate Change, SCCC, chaired by the Chief Secretary for Administration, was established in 2016. The SCCC was then upgraded to Steering Committee on Climate Change and Carbon Neutrality, chaired by Chief Executive, in mid-2021 to formulate the overall strategy at the highest level. The government also established in 2016 the Climate Change Working Group on Infrastructure under the leadership of CEDD to coordinate effort of Works Department, the Buildings Department, the Hong Kong Observatory in adapting to climate change, focusing on enhancing adaptation and resilience of government infrastructures. The working group aligns the design standard to cope with climate change extreme weather with reference to the IPCC AL6 report. And the working group coordinates effort to strengthen infrastructure and to enhance their climate resilience. The working group also coordinates climate change studies. The CCWGI also share relevant experiences with public organizations, utility undertakers, airport authorities, and MTR, thereby enhancing the overall infrastructure resilience of our city. With the progressive release of IPCC AL6 report since August 2021, the CCWGI takes into account the relevant assessment report and analyzed climate change parameters, including temperature increase, sea level rise, wind speed increase, storm surge increase, rainfall increase. Based on like parameters, we have already completed update of CED Portworth Design Manual and DSD Strong Water Drainage Manual in August 2022. The review and update of other infrastructure design guidelines and manuals will follow in 2023. We prioritize our effort on enhancing the resilience of government in critical infrastructure. The CCWGI completed the resilience study of government CI in 2020, having identified around 350 numbers of critical infrastructure in 7 categories, with consideration of hazards include landslide, coastal flooding, and structural damages. The relevant government departments are now formulating measures in implementation plans to enhance their CI's resilience. The working group has been coordinating studies related to the effect of extreme temperature, the resilience of government infrastructure, frequency analysis of extreme sea level, and increase in extreme wind speed, etc. This study aimed at providing updated climate change parameter, serving as reference on the design of enhancement measures, and providing information for emergency preparedness plans. I would like to share with you how we could deal with the rising sea level in built-up area. Climate change projections are developed based on a range of emission scenarios. With reference to IPCC AR6 report, there is insignificant difference in sea level rise projection under intermediate and very high greenhouse gas emission scenario in the mid-century, whereas the difference is increasing significantly towards the end of the century, demonstrating the increasing uncertainty with time. Considering the uncertainty in climate change development and the global action among nations on reducing carbon emissions, we adopt intermediate greenhouse gas emission scenario as a starting point, with addition of design allowance in our planning and design to cater for possible higher emission scenario towards the end of the century. How to cope with uncertainty in the long run? Aligning with overseas practices, we adopt a proactive adaptive approach to formulate climate adaptation measures for coastal infrastructures. As shown in the left diagram, we have to deal with increasing risk of coastal hazards. For enhancement of existing marine structure, we focus on medium term up to mid-century with more certain climate change projection. To enhance climate resilience on marine structures where practicable, design allowance is added for allowing future enhancement cope with higher emission scenario. For example, incorporate sufficient foundation capacity for raising the height of wavefall in the future. Under the progressive adaptive approach, we closely monitor the long-term climate change projection. In the right top diagram, if the long-term climate change projection follow the assumed scenario, timely upgrading the coastal structure could generally enable them to cope with the extreme weather at the end of the century. In the right bottom diagram, if the long-term climate change projection exceeds the assumed scenario, larger scale coastal projection measures could be planned to cater for coastal risk at the end of the century. This approach has advantage to avoid premature implementation of large-scale adaptation measures and to reduce maintenance operating costs. In built-up area where space is scarce, we could recommend to adopt multi-layer enhancement approach to deal with extreme weather and rising seawater level. Firstly, constructing or raising wavefall along the coastline. Secondly, installing flood barrier at suitable places behind the coastline to prevent the water gushing into the inland areas. Third, installing demandable flood barrier at building frontages as a last line of defense. Apart from the infrastructure enhancement, I would like to stress that it is equally important to identify appropriate management measures. Measure 2 and 3 are expedient measures that should be implemented only when necessary. Public awareness and preparedness are equally important. Early warning system and emergency preparedness plan shall be in place. These are common examples of measures 1 to 3 as introduced in the previous slide. For new development, we have the possibility to adopt the sponge city concept to cope with the climate change hazards. As example, for new development, we shall consider to adopt a sponge city concept by incorporating a sustainable drainage system, such as putting up porous pavement, bios valves, attenuation and treatment ponds to enhance cities' resilience to rising seawater and flood risk. We also consider to construct more desalinating plants for enhancing the water supply resilience against extreme drought. How about the resilient measures at new coastal development areas? Coastal buffer zone, flood resilient concept, and the progressive adaptive approach may be introduced in land use planning and zoning stages. Coastal buffer zone, making use of the space near seafront to confine the flood extent and to defend the development behind against wave attack. The possible flood impact to the development due to wave overtopping will be alleviated. To sum up, CEDD emphasis both climate mitigation and adaptation in taking forward our projects. CEDD will continue to flourish carbon neutral community and work in concerted effort with other departments to make our infrastructure more climate resilient. While the success of WOW requires the participation and support of the whole community, CEDD will keep in view the latest development of climate change emission pathway, strive for innovations, and adopt a progressive adaptive approach to build a climate city, ready city for people to live, work, and play. That's the end of my presentation. Thank you.
Thank you, Ricky. It's very good to hear how hard your steering committee, your working group has been working. Now, what we're going to do now is I'm going to invite the rest of the panel, the government speakers, to come on stage and take their seats. The first one who will talk after Ricky is Alice Pang, who's the Director of Drainage Services. So Alice. And the others are Dr. Raymond Chung, who's the head of Geotechnical Engineering Office of CEDD, Dr. LEUNG Siu Fai, who's the Director of Agriculture, Fisheries, and Conservation Department, Mr. Kelvin Low, who's the Director of Water Supplies, Engineer Kevin Yeung, the Chief Building Services Engineer of the Architectural Services Department, and Engineer Henry Chang, who's the Chief Building Services Engineer of the Housing Department. So please come on stage and take your seats. And Alice, please come to the podium. I just want to say that it's very unique to have this number and this range of government officials who will explain to us in one short presentation all the important work that they are doing. So please, Alice.
Secretary for Environment and Ecology, Mr. ZHAI, Undersecretary for Development, Mr. Lam, Mr. Goh, Professor Low, honorable guests, professors, distinguished speakers, ladies and gentlemen, good morning. I also welcome students from schools to join and also the online friends. It's my pleasure to share the Drainage Services Department's journey towards a green and smart transformation for climate adaptation. Adapting to flood risks arising from extreme weather is definitely full of challenges. If you are post-90s generation, you may not have seen these major flooding events that we experienced some decades ago in Hong Kong. Is it alarming? Maybe it's very alarming to some of you, right? But these scenes may not be happening nowadays because we have strategically completed a series of flood prevention measures, including stormwater interception, flood storage, and drainage improvements, and have successfully eliminated 127 flooding black spots. We will continue our work to remove the remaining 4 flooding black spots. Adapting to flood risks arising from extreme weather is full of challenges, as I mentioned just now. DSD was awarded the Dr. Norman Quintana Award 2019, which is a great encouragement to our colleagues. It recognized our contribution towards flood prevention, including long-term planning of drainage facilities and timely efforts in minimizing flood risk due to the super typhoons Hato and Mangkhut. Faced with the challenges brought by climate change, our drainage design philosophy is undergoing an evolution on enhancing both adaptation and resilience. That is, besides straightforward infrastructure for flood alleviation, we need to be people-oriented, ecology-directed, and smart-driven so as to push forward sustainable development and build a livable city. More importantly, this design have to be embedded in the early planning stage. We all know that land in Hong Kong is very precious. With this in mind, we have adopted the land co-use concept to locate the stormwater drain storage tanks under playgrounds and football pitches. In our Tai Han Dong underground stormwater storage tank, we had a pilot to organize an art exhibition for the public to visit this underground world during the dry season. Some of you may have visited this, I think, this exhibition before, right? In the upcoming stormwater storage schemes, we will explore more opportunities for land co-use concept. For example, in the Shek Kip Mei stormwater storage scheme, we will adopt an open tank design and integrate it with the Shek Kip Mei Park. Here we have infinite possibilities for leisure activities during dry days, like art performances and exhibition, as well as other active and passive uses. In new development areas, we have brought in the concept of floodable areas. In normal days, it can be a lake park or basketball courts. During heavy rains, it can be used as a temporary stormwater storage basin. We have new opportunities to promote climate resilience at the early land planning stage. For example, we have collaborating with the Civil Engineering and Development Department to build a flood lake under the Anderson Road Quarry Development Project. The public can enjoy the area in normal weather days. Just imagine, you can lie down on the lawn, walking along the floating bridge, sit by the lake, and enjoy the landscape. Thanks to the effort of CEDD colleagues, the works will be completed very soon. Since end of last century, we start to incorporate greenings, ecological and water landscape features in different river training works for flood control, such as Ung Tong River, Ho Chung River, and Yuen Long Bypass Floodway. More river revitalization projects are in the pipeline. The outcomes of the recently completed Jordan Valley channels are encouraging. We have successfully transformed a concrete NOLA to a river garden. This year, we have discovered many species enjoying the revitalized river, including some long-awaited wildlife. These rare riverine species attract many local wildlife photographers flocking to the river to take a good shot. In the ongoing Choi Ping River project, we are revitalizing the concrete NOLA into a lively river with green landscape, water-friendly facilities, open space, and walkway along and across the river. Other than those people-oriented, people-oriented features, the smart-driven elements will be manifest by an automatically operated smart water gate to regulate the water levels and creating a nice waterfall effect. Moving forward, we come up with another smart-driven solution to alleviate the flooding problems due to the high sea level and extreme rainwater in the Yuen Long low-lying inland area. You can see at the top, the Yuen Long Barrage scheme. It will be the first ever flood-controlled barrage in Hong Kong with a mega-sized pumping station. The barrage operation will be optimized based on the real-time tidal conditions, rainfall, and short-range weather nowcasting system. We also have the chance to revitalize the Yuen Long Town NOLA. The video at the bottom indicates that the existing concrete paved NOLA will be turned into a pleasant green corridor to enhance the public amenity of the Yuen Long Town Center. Climate change will bring more rainfall and typhoons. We need to enhance our operation by using smarter solutions. The series of videos at the top show some desilting robots we are using to clear our drainage system in a safer manner in both wet and dry seasons. The photos at the bottom left showed our hydrometric information system, which is an in-house developed smartphone application. We have monitored the real-time rainfall, river levels, tide levels and flooding situation from over 170 numbers of water level sensors, flow sensors, and CCTVs. With the support of local rainfall forecast technology, we will be able to carry out just-in-time clearance for our drainage system. We also make use of the innovative smart technology in creating more water-friendly facilities with river environment. The revitalization of the Taiwan Naula project, now under design, is exploring the adaptation of artificial intelligence with video analytics to ensure public safety and enable effective management of such a long river section. We have also been striving to reduce carbon emission with the use of renewable energy in our facilities, such as biogas, solar power, and hydropower. Among others, we have recently installed a couple of small-scale pilot floating PV systems in Santin Polder and Shingmun River. We will continuously identify more opportunities for renewable energy. In our Yunlong effluent polishing plant project, we have taken multiple measures to strive towards energy neutrality, such as minimizing energy consumption, using renewable energy and green building design, and the project won the prestigious 2022 Edmund Hambly Medal from the Institution of Civil Engineers. DSD will continue our effort in combating the climate change challenges and further collaborate with different institutions, academies, departments to enhance our city's resilience and make it more livable. Thank you.
Thank you, Alice. And I wish we had a lot more time because I think each one of those projects are really exciting. Next, may I ask Dr. Raymond Cheung from the Geotechnical Engineering Office.
Professor Gao, Professor Lok, Mr. Che, Mr. Chan, fellow professor, colleagues, students, friends, good morning. Well, today I'm going to share with you on the changing climate, how we adapt landslide risk in Hong Kong. Key message, fact, we are facing more frequent, more severe short-duration rainfall. This graph shows you the hourly rainfall records over the past 150 years. So the last records made in 2008. You can see the cumulative rainfall during the period of 6 to 8 June 2008. Hong Kong experienced a very severe rainstorm. We record a rolling 4-hour rainfall, the heaviest rainfall in Lantau. In terms of return periods, 1,000 years return period rainfall. The consequence. So we take stock. Hong Kong experienced more than 3,000 landslides spreading over different regions. But alone in Lantau, we record 2,050 landslides. So if you still remember, our northern Lantau Expressway is closed, and Taios was disconnected from other region, and 2 people were killed by landslide. But even under a normal day, on average, we still receive 200 to 300 landslide incidents reported by the public. Say, for instance, this year in June 8, you can see from the news, there's a small landslide in Sai Kung, but the landslide caused disruption to more than 400
people over a week. So what is the overall picture of landslide risk in Hong Kong? You can see from this graph. Before we set up the sub-safety system in 1977, the red bar showing the landslide fatality and the landslide risk keep increasing. But after we set up the sub-safety system, the landslide risk gradually decreased to a level of very low, but it's still there. In particular, currently, we are under climate change environment, our development, and the deterioration of slope. So I would say the landslide risk will keep increasing again if we do not input anymore, or I'm sure that landslide risk will not be zero. So that's important. So our strategy in future is to strengthen the preparedness to expect the unexpected scenario. First, of course, as an engineer, we would like to strengthen our slope using engineering means, but unlike conventional means, we would like to find robust, innovative measures. For example, we put reinforcement into the slope. We enhance our slope drainage according to the latest finding, for instance, the IPCC AR6. And sometimes, apart from fixing individual slope, we may do an engineering measure as a whole for a region. For instance, the Poshan drainage tunnel. Through the tunnel, we can control the groundwater in mid-level. In fact, Poshan drainage tunnel is not an ordinary tunnel. It is also an education center. So we renovate the tunnel to become a science technology chamber. We receive a public student, try to tell them what's landslide risk, what kind of measure was a self-help tips for them. And one particular characteristic of this tunnel, it is a digital twin. I will tell you later. So natural terrain, of course, we are developing different kind of innovative and green landslide risk mitigation measure. So slope information, slope management is important. Right now, we have a 2D slope information or geotechnical information infrastructure. You can retrieve all kinds of slope information. For example, geology, geometry, past record, history. Now we are building a 3D or even a 4D information system. For instance, here, it is a digital twin of Poshan drainage tunnel. We have many sorts of IoT sensor inside. I can receive instantly from our mobile device the groundwater level, the water pressure inside the hillside. Once the groundwater pressure exceeds a threshold level, then the drain pipe will automatically open and relieve the water pressure. Apart from this, we're also building digital twin for other engineering measures. For example, in our barrier system, we introduce an IoT system into it. For instance, in Queen Mary Hospital, we got all sorts of sensor, impact sensor, camera, depth gauge, etc. So once the debris hits the barrier, I can receive the information instantly. So we have a contingency plan, and also the people in the Queen Mary Hospital also got the contingency plan. They know what they do. So we are now expanding this smart system to other barrier systems. The second, of course, government emergency response capacity is very important. I would like to tell you that the landslip warning system in Hong Kong is the first in the world of this kind of regional system in the world. And we base on the past record of landslide, rainfall. We carry out some analysis, find out the correlation, and once a rainstorm comes in from the network rain gauge, and also with the help of a Hong Kong Observatory forecast, also it's important to report the landslide, because apart from doing computation, we have to know the reality. All these sort of information come in, and we can make a good prediction. With the prediction, we can liaise, coordinate with Hong Kong Observatory to see whether we should issue a landslide warning. That is important because based on our 30 or 40 record statistic, more than 90% of the fatal landslide incident occur within the landslide warning period. And apart from doing ourselves, we also have a collaboration with other countries. For instance, here, you can see a land aware. So we can discuss and exchange knowledge of this kind of system in the world, try to improve our system further. And right now, I know our team is going to making use of artificial intelligence, whether it can help in our system. So this is the next step we have to do. And satellite technology is also important, INSA. So every day, I receive a satellite image I can view the image from our desktop as well as the mobile device. So we can capture the response of the terrain after a rainstorm. And if necessary, we can make a request for a satellite to position a particular area of Hong Kong to get a high resolution information. So of course, I think you may be aware of that. The common operational picture, we developed this platform to share the information, the emergency information among different government departments and bureaus. So far, I think we have 20 departments join in, including bureaus. So we share the real-time information of all sorts of emergency cases, for instance, landslide, rainfall, flooding, traffic condition, etc. So we can, based on this, to make the necessary and timely follow-up. Right now, the landslide site is very dangerous, but we have to get immediate information. So instead of sending a man to go out, we are using robotics technology. Probably you have heard about the robot dogs. It can equip with various kind of sensor, laser, computer, robotic arm to get the site information. And one particular thing is characteristic of the robot is that it has a function of AI. So once you assign he or she to go a particular place, he or she can find the safe route himself or herself. And this year, we work with a local university, try to assemble a robot spider called Petteri. So we have a different kind of robot to help us to do the job safely. Well, this is the most important and our concern thing. It's about the public awareness of safety. We carry out survey every year. You can see from the graph that is quite alarming. The public today, I think more than half of the general public think that landslide safety is not a concern. We are very safe, okay? I think there's a wrong perception. So that's why we are doing more and more education, try to educate the public, tell them the risk there, and what would be the self-help tips, and try to increase the community resilience. Say, for instance, I just mentioned the Poshan drainage tunnel is one of the very good venue for us to do the job. Collaboration is important. We are not doing the job ourselves. So I think we have a long history to collaborate with academia, research institute, and industrial practitioner. I would say that there's an example here. There's a Center for Safety. We work with various universities, including, of course, Hong Kong UST and Hong Kong O, to try to understand the debris flow hazard. So I know we are building a test facility in Kwang-Ting. It's a very huge facility. It can make an artificial landslide of a volume of about 500 cubic meters. Of course, with the help of Chinese Academy of Science, hopefully it will be in full operation by the mid of next year. Finally, I would like to sum up that I think the common objective of all sort of things is we would like to build Hong Kong as a safe, sustainable, and livable city. We would like to attract more talents coming into Hong Kong. Thank you very much.
Thank you, Raymond. May I call upon LEUNG Siu Fai for his talk? You can sit or you can, up to you. Please, please. While Siu Fai get ready, I just want to say that I think what we have watched from GEO and also DSD are extremely exciting in terms of the work, but also the level of safety and reduction of risk that you have helped Hong Kong to achieve. So Siu Fai, please.
Okay. Hello, everybody. Good morning. Today I'm going to share with you our department, Agriculture, Fisheries and Conservation Department's work related to climate change. AFCD is a professional department responsible for nature conservation and also promoting the sustainable development of agriculture and fisheries. In the context of climate change, AFCD formulates and implements action plans for the conservation, management, and sustainable development of Hong Kong's natural habitats and resources, with a view to enhancing our capacity for climate mitigation and adaptation. So there are now altogether 24 country parks, 22 special areas, 8 marine parks and reserves under the management of our department, AFCD. These protected areas cover over 40% of land area in Hong Kong and around 4% of sea area of Hong Kong. Through active management and development control, we ensure that these natural habitats and their biodiversity are conserved and enhanced, thereby performing the important carbon sink function and contributing to our efforts in climate adaptation. In addition to the existing protected areas, we are now going to designate 2 more protected areas, namely the Robin Nest Country Park in the land, and also the North Lantau Marine Park in the sea. Upon completion of designation of these 2 new protected areas, there will be a further increase of over 2,900 hectares of land and sea area put under statutory control. Well, as you all know, forests serve as an important sink of greenhouse gases. So in order to increase the carbon sink capacity of the forest in country parks, AFCD will devote constant effort to afforestation and carry out an ongoing plantation enrichment program to change the exotic species into native species, so as to enhance the biodiversity and sustainability of our plantations. Furthermore, we put in place effective hill fire preventive system and measures to protect our forests from this disaster. So apart from forests, actually, coastal ecosystems, including wetlands, are increasingly recognized for their ability to sequester and store carbon. So in addition to their well-known functions for flood prevention and coastal protection, in Hong Kong, there are over 6,000 hectares of wetlands, of which about 1,500 hectares in the Maple and in the inner Deep Bay area has been listed as wetlands of international importance under the Ramsar Convention. AFCD will continue to implement, jointly with other government departments, a range of conservation and regulatory measures for the management of the area, as well as raising public awareness on the importance of such wetlands in terms of nature conservation and climate adaptation.
In October last year, the government announced the Northern Metropolis Development Strategy, under which it is proposed to establish a wetland conservation park system, altogether involving some 2,000 hectares of wetland, in order to create environmental capacity, as well as to achieve coexistence of development and conservation. The wetland park system would not only contribute to climate mitigation for Hong Kong, but also form an integral part of a blue-green infrastructure of the Northern Metropolis, and contribute to climate adaptation, wildfire protection, and coastal protection. So much so for the nature conservation. Now I would like to turn to the agriculture and fisheries. There is beyond doubt that climate change will affect the primary production systems, and hence have potential threats to our food supply and food security. So it is a global issue going to affect everyone in the world, including the people of Hong Kong. As such, we should strive to promote the sustainable development of agriculture and fisheries sector with a view to enhancing the climate mitigation and adaptation capacity of our food production systems. On the fishery front, our future focus will be put on aquaculture development, not capture, but of course aquaculture, to produce fresh food for our society. So in the coming few years, AFCD will focus its effort to designate more fish culture zones, make wise use of our wetland conservation park system for sustainable aquaculture development, develop strong resistant deep sea mariculture system like this one shown on the picture, as well as develop advanced technologies to increase our fishery production and enhance our resilience against extreme weather conditions. As regards agriculture, sustained efforts are devoted to developing and promoting the use of agro-technology and environmentally friendly farming practices, which will be conducive to increasing productivity and also reduce carbon footprint. We will also conduct more studies to select crop varieties that will be more adaptive or tolerant to climate change, and help farmers to set up greenhouses and rain shelters to protect their crops from extreme weather conditions. We will also continue to implement the new agriculture policy launched in 2016. In particular, we will take forward the initiative of establishment of the agri-park, protection of important agricultural land by designating agricultural priority areas, promoting agro-technology and the development of urban farming concept in the new development areas that will enhance our resilience and stability of our food supply systems against climate change. We also need to put more effort to build up the capacity of our fisheries and agriculture communities. That's why we have two sustainable development funds to help farmers and fishermen to develop sustainable and environmentally friendly practices that will help them build up their mitigation and adaptation capacity for climate change. So that's all for my presentation, but before I finish my talk, I would like to emphasize that AFCD will continue to collaborate with other Bureaux and Departments, the NGOs and also private sectors to conserve our precious natural resources and habitats and continue to promote the sustainable development of our agriculture and fisheries with a view to enhancing our capability to combat climate change. Thank you very much.
Thank you, Siu Fai. Thank you. Well, I guess many of you know that Hong Kong, although it's a very small place, has amazing biodiversity, but probably we don't hear enough about what we can do for agriculture and fisheries and how they are relevant to climate change. So our next speaker is Kelvin Low, who's the Director of Water Supplies. Thank you.
Okay. Good morning, distinguished guests, ladies and gentlemen, and also students. It's my great pleasure to share with you more matters on climate adaptation. First, let's take a look of the demand and supply figures in last year. So amounts of the total water consumption, the fresh water consumption account about 990 million cubic meter, about 72% of the total, whereas the flushing water account for the remaining 28%. On supply side, Dongjiang water contribute about 60%, local yield contribute about 18%. For the remaining, in fact, Hong Kong is a pioneer city adopting seawater for flushing extensively, so seawater's share is about 18%. So how about the future? In fact, we forecast the annual freshwater consumption will increase to 1,110 million cubic meter a year. So this is a big challenge to the water sustainability. Another challenge you can see from the graph is that our domestic consumption is very high as compared with the global average and other world cities. So on supply side, climate change will impact on local yield as well as the yield in the Pearl River Delta Basin. So as manifest in the drought in Guangdong province last year, we need to diversify the resources, the water resources, to ensure water security. Our current water supply portfolio has been structured to secure 99% reliability, assuming that management measure is in place to contain the demand, and also the climate change impact is within our expectation. However, if the demand cannot be managed and the climate change impact is worse than expected, so what is the reliability? The reliability will alarmingly drop to 40%. So what does it mean? It means that we will suffer water shortage and we will have to implement water rationing nearly every 2 years. So that we have to prepare for this worst case. So to better ensure water security, we launched the Total Water Management Strategy, focusing on demand management and supply diversification. So they comprise 5 key measures: water conservation, water loss management, increasing our local yield, using low-grade water, and desalination. So the demand management measures, including promotion of water conservation and water loss management, are to contain the overall demand to under 1,000 million cubic meter a year, up to 2040. So the water saving can also reduce our energy consumption by 60 gigawatt hours a year, and also help decarbonization. So in our soft approach of water conservation, we will sustain our effort on public education and publicity. We are going to include in our water bills, apart from the domestic consumption, we will also include the key performance benchmark for high water consumption trades. On the other hand, we will adopt a hard approach to enhance water use efficiency by mandating water efficiency labeling scheme for water using apparatus, and also adopting advanced metering infrastructure for statutory requirements. Capitalizing the BEAM plus assessment for GFA concession, we will incentivize the water-saving design. For water loss management, We are progressively establishing a water intelligence network by 2040. So by that time, we can then better identify anomalies with IoTs and take prompt action to curb the water loss for these individual areas. Under our risk-based mains management improvement program, the water mains will be prioritized for replacement according to their failure risk. So the failure risk we will take into account the age and material of the water mains, and also their failure records and consequence. We will also implement water loss chargings on private mains through the legislative amendments to the Waterworks Ordinance and regulations. So all depends on the effectiveness of the above measures. The freshwater consumption can be reduced by about 10 to 12% or more from the current level. So on the supply side, we will pursue supply diversification to cope with the demands and the climate change impact. With potential overflow, transfer from the Kowloon by Wash Reservoir to Lower Singmun Reservoir. The inter-reservoir transfer scheme can provide an extra local yield of about 3 million cubic meters each year. So other measures like reactivation of mobile water treatment works and also expansion of our water gathering grounds we will also consider to facilitate utilization of more local yield. We are also extending the non-potable use of lower grade water, including seawater and recycled water, from the current 85% population coverage to 90%. So recycled water is in fact a shortcut of water cycle and is not subject to climate change. So there will be room for our use of this recycled water in new development areas and large-scale redevelopment areas. Water Supply Department and Drainage Services Department will work in synergy to increase the overall cost effectiveness of recycled water, taking into account the sewerage and water treatments in a holistic manner. So if necessary, under the increasing threat of climate change, we may also consider non-domestic use of the recycled water. On supply diversification, despite its energy intensiveness, desalination is a strategic portable water resources not subject to climate change. So the first stage of WSD's Jiangguan desalination plant will be commissioned next year to produce extra water supply of 50 million cubic meters each year. To prepare for the more severe climate change impact, we are planning to advance the second stage to double the production. So with the demand management and supply diversification, we can maintain 99% water security amid the expected reduction of yield due to climate change. We also build in some contingency to meet worse than expected drop up to 50 million cubic meter reduction of local yield. So in addition to ensuring water security for climate change, we drive decarbonization through technologies and innovation. Pumping operation accounts for about 90% of our energy consumption in our daily operation of our water supply network. So we have taken forward a number of measures to enhance the pumping efficiency. We are also progressively adopting digital trends of water treatment works and water supply network so as to anticipate operational problems, optimize the operation, and also reduce the water loss and energy consumption. So in addition, we also adopt sustainable design, building design in our project to reduce water usage and carbon footprint. Take for example, the Jiangguan desalination plant, we include the rooftop PV panels, as well as building solar farms at the Southeast landfill to supply renewable energy to the plant. So capitalizing the very large area of our impounding festivals, enjoying the successful experience of pilots installed at the Sepik, Pulver Cove, and Dai Lam Chung festivals, we are planning much larger scale floating solar farm at these 3 reservoirs. In parallel, we are also exploring the feasibility of a mega solar farm, floating solar farm at Pulver Cove Reservoir. Our plan is to increase progressively the renewable energy generation capacity up to 160 gigawatt-hour per year by 2035 onwards. This will offset about 20% of the department's total energy consumption. This is equivalent to 0.35% of Hong Kong's total consumption. So in fact, WSD has embedded climate adaptation into our planning and strategy of securing water sustainability. We look forward to collaborating with every concerned party and the public to build a sustainable future together. Thank you.
Thank you, Kelvin. And whilst Ken gets ready for his presentation, I just want to remind everyone that you said something really important, and it's that water use and energy use goes together. So the more that you're able to save water, the more we can save energy. Ken Yeung, please go ahead.
Okay, thank you. Professor Kwok, Professor Lok, fellow guests, fellow students, good morning. Cordially thank Hong Kong UST for the invitation. It's my pleasure to join such a meaningful event to share with all of you our architectural services department's strategies and experience in building beyond the climate challenges. Our department is fully committed to deliver our projects and services in a responsible environmental manner under 3 core strategic directions, the 3 A's: accurate, accommodate, and agile. For our first direction, accurate, we adopt a scientific approach in our integrated design process to optimize the building design adapting to the climate challenges. We conduct performance-based engineering analysis, such as wind analysis, daylight and solar analysis, etc., to scientifically shape the building architecture in order to optimize the energy-saving benefits of the buildings and minimize the impacts of buildings on surrounding microclimate. To further confirm our commitment to providing quality green and sustainable buildings, we are committed to at least obtaining gold rating in the local comprehensive green building assessment scheme, BIMPAS, for our projects. As of June 2022, we have 79 projects attaining gold rating or above in BIMPAS, and 21 of these projects attained the highest platinum rating, accounting for about 50% of all platinum projects in Hong Kong. Our second strategic direction is accommodate. We fully recognize our roles in building our city's climate adaptive capacity and resilience. We integrate diversified social considerations in our projects and services to strengthen the design of public facilities and government buildings to protect the life, health, and property from extreme weather. I believe all Hong Kong citizens still remember the power of the super typhoon Mangku in 2018. This is one of the strongest typhoons in Hong Kong's history, severely damaged the power supply, track, and grass pitch of the ZHAI sports ground. To mitigate the damage caused and also to enhance our facility preparedness for future extreme weather conditions, our team reacted promptly to come up with an enhancement work plan to extend the existing boundary wall and add new boundary wall. To provide a quick response to relieve the adverse impact on nearby residents, we also adopted the DFMA approach for the remedial works. This greatly increased the efficiency in manufacture and assembly of the raw modules, with enhanced quality. Eventually, we completed all the work within 6 months. To tackle extreme weather, especially rainstorm, we have further studied the integration of spongy city concept in our projects. Convey, infiltrate, trip, detain, and store are the 5 main systems under the spongy city concept. The graphic in this slide gives a brief idea on these features in an open space project. These photos illustrate some of the spongy city features. In addition to open space, we are also studying the application of spongy city concept to other projects, such as schools, sports complexes, theaters, and office buildings, etc. With these studies going on, we strive to develop and lay a solid foundation for a comprehensive strategy on climate change adaptation and strengthen the resilience for the community. Our first strategy is agile. We always keep exploring and adopting best practices and cutting-edge technologies in our projects in order to groom the agility of our team against climate challenges. We have set up a Design for Resilience working group to, first, acquire new climate-related and sustainable building knowledge from global practices. Second, identify appropriate projects to carry out field trials. And third, develop best practices and design guides against adverse weather, epidemic, vandalism, etc. We engage stakeholders through various communication channels and platforms to regularly review and update our general specifications in order to build a future of public architecture in a way that is climate adaptive, resilient, and sustainable above all. Buildings in Hong Kong account for about 90% of the city's electricity consumption, and over 60% of our carbon emissions are attributable to generating electricity for buildings. To set a good example for community, we have been proactively incorporating green and low carbon elements in our projects with the aim of leading and encouraging decarbonization in building sector in order to advance towards the direction of carbon neutrality by 2050. We proactively incorporate renewable energy technologies such as PV panels in all our projects. We have set an internal environmental target that for new works project with CFA more than 10,000 square meters, renewable energy technologies should be provided to contribute at least 1.5% of total energy consumption for general power and lighting, or to cover at least 25% of available roof space. We also proactively adopt renewable energy technologies in existing government buildings, venues, and community facilities to lead and encourage the industry in wider application of renewable energy in Hong Kong. As of June 2022, around 3 million kilowatt-hours of electricity can be generated by the renewable energy facilities of our projects each year. This amount of electricity is sufficient for the use by around 11,000 households. Throughout the years, we pay close attention to and fully utilize any improvement opportunities brought about by green innovation development, especially green materials and innovative construction methods, in order to shift to make breakthrough in our projects and advance in the carbon neutrality journey. In the future, you can see more and more low-carbon design concepts and features adopted in our projects, such as the toilet box at Park Garden of Central and Western District Promenade shown in this slide, or the Chinese Medicine Hospital in Jiangguan-O shown in this slide. Welcome you all to pay a visit to these low-carbon facilities and check in there after their completion in the coming years. Now, we all can see and feel the threats brought about by climate change. Our Architectural Service Department, as the major government department responsible for the development and maintenance of Hong Kong public building facilities, will embrace the duties to build beyond climate challenges. We will keep working hand in hand with all stakeholders to develop, apply, and promote best practices on climate adaptive, resilient, and sustainable building design. Let's work together to make our future sustainable. Many thanks.
Thank you. Thank you, Ken. Our last speaker is Henry Chang from the Housing Department. Whilst Henry gets ready, I just want to say that I know at ASD how hard you always work to design the nicest possible institutions and structures at the least cost, which is always a big challenge. Henry, please.
Thank you. Thank you for having me here to talk about and share with you the measures taken by the Housing Department towards the climate adaptive public housing design. And many of the topics have been covered by speakers before me, so I'll be quick. So climate change brings about extreme weather. We have to be adaptive and build resilience into our building design. There's no dispute that we all share the responsibility for combating climate change as an individual, a family, a community, private corporation, or public organization. So, Secretary for the Environment and Ecology has already covered Hong Kong's climate action plan, and he set out the vision of zero carbon emissions, livable city, sustainable development, with 4 major decarbonization strategies. Among them, energy saving and green buildings are of particular relevance to the Housing Department. As the largest developer in Hong Kong, with a stock of around 800,000 domestic flats and growing, we have been exploring and incorporating sustainable initiatives in public housing design and construction. We are committed to finding and utilizing innovative solutions to reduce our environmental footprints during construction and operations of the building. So just to name a few, at design stage, we use microclimate studies and passive design to maximize daylight utilization, natural ventilation, and building envelope thermal performance. We also developed a carbon emission estimation tool to estimate emission level throughout the life cycle of a building. This tool helps us compare design options and optimize and fine-tune our design. We also target all our buildings and developments to achieve at least gold rating in the BEAM Plus assessment, and some of them even achieved platinum rating. On the construction front, we have been pioneer in Hong Kong to adopt large-scale prefabrication construction process, which reduced significantly large amount of construction weight on site. So to go further, we are actively exploring new technology and innovative high productivity construction methods, such as the MIC and MIMEP, which on the one hand enhance productivity and quality, and on the other, it also greatly reduces construction waste and reduce its impact to the environment. So on the energy front, the government has set out a goal to reduce energy consumption of residential buildings by 20 to 30% by 2050. Since around 30% of the Hong Kong population resides in public housing estates, we have a major role to play in achieving this goal. We have established an energy performance indicator to govern the maximum energy consumption for communal services in our building, which includes public lighting, elevators, water pumps, ventilation system, etc. Over the years, we have tightened the indicator whenever new energy initiatives are adopted, such as the extensive adoption of LED lighting in 2016. We lowered the indicator from 27 to 24 kWh per meter square per annum. And we just do not stop there at the design stage. We conduct energy consumption measurement after mass intake of tenants for 1 full year to verify our design consumption, assumption, and make improvement as required. The energy performance is achieved through a number of energy-saving initiatives, which are standard provisions in our public housing, which includes full adoption of LED lighting, two-level lighting control, adoption of energy-efficient equipment, power-generative lifts. We also want to educate our tenants by installing a smart meter monitoring and energy display system in each of the domestic block lobby in order to promote their awareness towards environmental issues. And to support the government's green transport initiative, all our new car parks are 100% EV enabled, with 30% equipped with EV chargers. We are also at the forefront of using renewable energy. Since 2011, we have been installing grid-connected PV systems in all our new public rental housings. As of today, we have already installed PV systems in over 140 buildings. Through the adoption of the initiatives, housing department strives to make our housing estates more resilient and sustainable against the challenges posed by the climate change. There's a saying that many a little makes a miracle. Housing department is committed to minimizing our environmental footprints in the development of public housing and creating a green and healthy environment for our residents. Thank you.
Thank you. Thank you, Henry. Well, I have to ask for the audience indulgence. I know we're a little behind time, but I think you have never seen such an extensive presentation from such a large group of government officials. So I hope you were greatly entertained. Now, I do want to ask a few questions, for you to ask a few questions, because I know I was told a number of students earlier on would have 1 or 2 questions to ask. But before I do that, so if you do have questions, please get ready. And I'd like to invite Tim Chang from HKUST to actually come and give us a formal vote of thanks, because it wasn't possible to do this without actually working with a lot of people. So Tim, please.
All right. Yes, I think on behalf of HKUST, we really want to express our appreciations to government officials and leaders from various bureaus and departments for your contributions and your support to CARE2022, which without your support, this will not be able to achieve these amazing results. And I think also the audience agree with me the last 100 minutes that we have learned tremendously from your sharing. I think I personally really enjoy all the information, but more than that, it's very comforting to know that we're in good hands. The government's strong effort of adaptation and preparation for possible disruptions caused by climate change and the environment challenges. I think as a citizen, we really appreciate your effort. So in response, I want to spend maybe just 3 minutes to share what HKUST has been working on to address this important issue. I think shortly after government's pledge to commit to net zero carbon neutrality by 2050, HKUST immediately make the same pledge to commit for a net zero campus by 2050 as well. But we're not just talk the talk, we walk the walk, that we have established a series of measures. And I'd like to highlight a couple of areas that to show how HKUST support the cities and nation's sustainability goal. First is our, as a university, we are focusing on education. So we feel the most important thing for a university to do is to nurture the next generation who will keep sustainability in mind throughout their whole career, for every single decision in their private life, for their work decisions. So I'm pleased to report that more than 90% of our students before they graduate, they took at least one sustainability courses. And more than 2/3 of them take at least 2 sustainability courses before they graduate. And last September, we announced the city's first Green Finance undergraduate program. We offer Bachelor of Science in Sustainable and Green Finance. And then another quickly on the direction of promoting a greener and more sustainable environment and lifestyle. HKUST, I think as a research university, we feel what we can contribute is through our research effort, we produce technology and results to help sustainability address climate change. I highlight a couple areas. Just 4 years ago, the university committed $50 million to launch a sustainable smart campus as a living lab scheme to support new ideas from faculty, students, staff, so that they can try their innovative idea on sustainability on campus. And those results can later transfer into the city, into their workplace. So I'm pleased to report that we have 30 projects, some of them being completed, some still ongoing, which include, for example, AI sensing for food waste analytics. If you go to our canteen, we have some canteen with camera installed without infringing privacy. Actually, it's from top, only look at the plates. Then we will be able to analyze food waste data. And we have digital twins of the entire campus. We have a novel automated aquaponics system and some unique carbon removal technology being deployed. Those are just small sample of projects. And also you have heard from the news, we have one of the biggest deployment of a solar panel system. Just on this campus with around 60 hackers, we have more than 8,000 solar panels installed around 50 different locations on campus. And this shows our commitment. And the other important direction is technology research. So just as recent as yesterday, our Energy Institute have a technology showcase, demonstrate various renewable technology for energy generation, as well as for battery technology for storage and delivery system. Another important point, I think in day 3, some of the leaders of our recent SIM-based project funded by UGC on green finance, our business school dean, Professor Tan, as well as other project leaders will showcase how the recent project on analyzing the current manpower demographics in the green finance sector in Hong Kong and advise the kind of talents we need in this sector. Again, I think university for talent nurturing is a very important task. And another thing worth mentioning is many of you heard about our new Guangzhou campus. As a new campus from day zero for campus master planning, achieve net zero with a very sustainable campus has been the highest priority. So with that, last thing I would like to mention is we realize just even as a campus, which is mini city, coordinating for net zero is enormous effort. So we recently established a net zero office, which can coordinate across different schools, departments, units to formulate strategies for a very ambitious sustainability goal. We want to achieve 15% reduction in energy consumption, 75% reduction in waste by 2028, in comparison with 2014's baseline results. So with this, I hope that you can sense that HKUST, we thank all the organizers, Professor Christine and the team, different school, for organizing CARE2022. And we show our commitment. And your presence today really demonstrates everybody's commitment to join hands, government, industry, academic, students, to make our tomorrows better. Thank you.
Thank you. Okay, we're going to take just 5 minutes out of your lunchtime. Were there some young people who wanted to ask questions? Can I have a show of hands? Where are you sitting? Those who wanted to ask questions? Can you come to the mic? We will take 2 questions. Thank you. Tell us your name and your school, please.
I'm Harris from St. Paul's College, and I'm one of the students, sustainable student ambassadors from the college as well. It is up to everybody to figure out how to contribute, and the education sector has to come together to find a solution and address climate change. Currently, there are 451 secondary schools that are contributing to Hong Kong's huge carbon footprint. We're hoping that the government could involve students more in tackling this huge crisis. For example, could the Agriculture, Fishery and Conservation Department provide more technical support for schools to develop biodiversity? Besides that, could the Water Supplies Department also introduce more water conservation initiatives for students to participate in?
Well, thank you very much. Is there one more question that we can take? Is there another student who's interested to ask a question?
Thank you, Christina. Just now, Engineer Ken mentioned that in housing projects, you adopted the carbon footprint estimation in your project design stage. I think that's a very good move, and that's quite important because what gets measured gets done, right? So my question is for other directors. So will you consider adopting the same practice in your responsible works area, like for drainage works, for water works, or for all other types of government works? Thank you.
Okay, thank you. You will have a chance at workshop A to drill down a little bit more on these questions. So anyway, we are running out of time. So perhaps I can ask AFCD and water supplies to answer the question from the student first, and then maybe a one-liner from each of the others so we could round off this morning. Siu Fai.
Okay. So thank you for the student's question. The simple answer is, of course, yes. Actually, AFCD has been running an extensive school programs on nature conservation, our country park and marine parks, as well as agriculture and fisheries projects. So we can reach out to more schools in the future about if your school want to practice some sort of farming in the school, maybe make use of the roof area, or do some nature conservation projects for your class or for the students of old school. So if you need any assistance, please come forward and approach us. Okay, we will sure you to make use of our available resources to help.
Terrific. Kelvin.
Thank you. Indeed, I mean, getting schools or students to make some physical measures to produce potable water is very difficult because it has to meet a very stringent standard. But producing non-potable water may be much more easier. So we back to the very original. In fact, reducing water demands is a more preferable solution than generating additional supply. So all of you know that each citizen in Hong Kong actually each day consume more than 130 liters of water. That's much higher than the global average of 110. So if everyone, of course the student, can adopt some sort or shift the attitude or change the habit to a more water conservation mind, then each one can of course have a family and they can spread the idea. So that will amount to a very big saving in water supply. So I think that's the thing the student can do. That's one thing. Positively, they can also join our ambassador scheme to promote that water saving concept. Yeah.
Hey, terrific. Well, perhaps for each one of the other officials, just one liner. I mean, young people obviously want to be involved in some ways. Could your department or something to do with your work that you can engage more with young people from high schools and university? Yike, would you like to go first?
Actually, what I just presented in the 15 minutes of my presentation, we are always mindful of to reduce carbon footprint in taking forward all our projects. When we carry out every project, we normally involve public engagements, and we expect more voices from the general public, in particular the young people, not necessarily the students, young people to come forward to give their ideas how we can make our city more livable, in particular in reducing the carbon footprints. So we are very welcome to everybody of the society. When we carry out public engagement, please come forward and tell what's in your mind.
Alice?
Yes, in fact, actually, Drainage Services Department is very keen to give opportunities to all students. In fact, we have many guided tours. Even today, we have guided tours for our river revitalization projects. We have open days, these 2 days as well. And we welcome schools to organize school trips to our facilities. We have a lot to showcase. In fact, we have rivers, we have renewable energies, we even have sewage treatment plants to showcase. And also, we have school talks as well. And recently, we have developed our Facebook page and also the IG. Please feel free to like us. We are the Drainy. It's quite popular nowadays. And then we have messages. Also, when you visit our webpage, you can find a lot of useful information. Every year, we publish a sustainability report. There's a lot of information how we are going to tackle the climate challenges. So please feel free to visit our webpage. Thank you.
Raymond.
Yes, geotechnical engineering always always keen to engage young people, in particular school students. There is a school ambassador program in our office. I think we have already visited more than 90 schools, secondary or primary school. Our staff will go into the school and give a lecture to them and tell them what's the landside risk, geology in Hong Kong, etc. Apart from this, we have, as I mentioned before, the Poshan Tunnel. I think every week we have a tour to that center to do the public education. And also, we work with the education organization. Say, for instance, last year, you remember there's a landslide warning system in our office. We try to give organize a competition, give the student, probably secondary school student, the rainfall scenario and the stock information. And they work themselves to develop an algorithm to do the prediction. So sometimes it give an insight to our staff. I think it's very good. And also we work with an education bureau to develop an education kits to deliver them to the secondary school students. I think we are keen on this aspect.
Thank you. Ken?
Yeah, thank you. Indeed, the whole engineering industry is very eager to engage young people, our future generation nowadays. Actually, our architectural department built many schools for Hong Kong. Indeed, in the newly built schools, we implement many energy efficiency features in the school. For example, I think many students may be familiar with is the PV panels on the roof. Nowadays, besides these traditional PV panels, there are many other types or innovative type of PV panels, such as flexible PV panel, the BI PV panel, etc. When we nowadays implement these features in the school, we also discuss with the school operators how can we display some information for the students to learn about in the future. For example, we will implement a panel to show the energy generation by the PV panels in the classroom or in the school halls, so that as an educational purpose. We will continue to try to do these educational actions for the schools. Thank you.
Thank you. Last comment from Henry.
Yes, our housing department has a summer program for students. Actually, we have engaged them in some of our interesting projects, like environmental projects, traffic study, or all sorts of interesting subjects for the students in the summer program. And in fact, we don't want to just engage students. We want to engage all the people living in our estates because we have from time to time organized programs with the environmental protection department on recycling subject, on waste management, on energy efficiency, all sorts of stuff. So we actually welcome people from all walks of life from Hong Kong in our estate to join us in the programs.
Right. Please thank, together with me, the different departments and the government officials who've spent a lot of time with us today. Thank you so much. Now over to the MC to tell us what's next.
Thank you, and thank you all once again. Please proceed to the audience seat. Thank you. Please give a big round of applause to all of the heads of government departments and our speakers today for them to bringing us insights and inspiration on climate adaptation needs and efforts in Hong Kong. Due to the time constraint, we may not be able to address all the questions here. If you do have questions for our speakers today, please feel free to contact our staff and leave us a note. We will get back to you in due course. And that concludes our morning plenaries. We are deeply honored to have all the representatives today to share their views at CARE2022 conference. We would also like to extend our gratitude once again to you all for your kind support. And it now comes to our lunch break. A few tips for lunch at HKUST. For locations, there's a map on your badge. And also for caterer information, please scan the QR code at the back of your badge. And for tomorrow, there will be another set of meal coupon available for pickup. Please keep the badge with you for this afternoon's and tomorrow's workshop. For more information, please feel free to ask our staff for assistance. Once again, on behalf of the Hong Kong University of Science and Technology CARE2022 program, thank you very much. Enjoy your lunch break, and we'll see you in the afternoon workshops. Have a nice day.